Hey everyone, and welcome to Chapter 5 of Psych 3510. In this chapter, we're going to be discussing measurement, and specifically how we can identify types of variables, types of measurements, and then how we evaluate whether something is a good measurement or a bad measurement. Everything in this class is important, but this might be one of, if not the most important point or topic in the class, for the very simple reason that it doesn't matter how good your idea is. It doesn't matter how well you set up your experiment. It doesn't matter how good you are at statistics. It doesn't matter how many participants you have if you have terrible measurements, right? It doesn't matter. Nothing else matters if you can't effectively and adequately measure the things that you're trying to measure for your experiment. So measurement is a foundational issue in research methods, and might be the most critical or one of the most critical aspects to an experiment is ensuring that you have good measurement, right? If I'm interested in studying IQ, and I have a made up terrible version of an IQ test that my little sister made, right? Then who cares? It doesn't matter the question I'm asking if the way I measure IQ doesn't make any sense, right? If the measurement tool is bad, then everything is bad. The whole experiment is for nothing. Okay, so we're going to discuss ways to measure variables, different types of variables, and then a couple major sort of conceptual issues like reliability, meaning can you consistently get scores on a measure that are stable when they're supposed to be stable? And then the validity of our measurement tool. Is it actually measuring what we think it's measuring? And this is actually more difficult than it may appear. Okay, so one of the first issues in measurement is something we've already talked about, which is operationalizing our variables. And operationalizing really is the process of going from a conceptual variable to a real physical measurement. So as we discussed before, there are often many different ways that we can operationalize a given variable. Here are just a couple examples. So let's just take gender, right, which seems super easy. Let's just ask people whether they identify as male, female, or other. However, you could imagine a more crude measurement of gender, such as using the sound of a person's voice to assume what gender they are, right? There's going to be some inaccuracy there. That's probably a poor operationalization of the variable. We want to just ask them whether they're male, whether they identify as male, female, or other. Wealth, we could ask people to report their income, or for example, we could code from maybe 1 to 5 the level or status of their car. Presumably, people with crappy cars are less wealthy. People with really fancy cars are more wealthy. So we can see that there might be a disconnect between someone's income and the car they drive, right? Someone might make a lot of money, but not value having a really nice car. So they might make $1 million a year, but they have an average car. They've got, a really nice Toyota or something. They don't drive a Maserati. So the way we decide to measure something like wealth really matters. And of course, psychology is full of these conceptual variables like well-being or happiness. And for most of these types of variables, things like depression, anxiety, happiness, right? Satisfaction with your life, right? These sort of conceptual psychological variables. Scientists have developed scales that we have measurements that are like surveys that have been studied. Right? There are actually people who their area of expertise is creating these surveys and developing them. And so we have things like the 10-point ladder of life satisfaction, or ladder of life scale, right, to measure happiness. This is a 10-item scale or survey that has been used in the literature. It's been cited. We know how it sort of functions and what it does. But there are others, right? There's not just one scale. You might also use the Diener's 5-item subjective well-being scale. So, what variables like this and these scales show us is that we have to put a lot of work and effort into creating these things. And if you're going to use one of them, making sure that you make the right choice about which one you're using. And so we're going to talk about that today and some ways that we can start to make those decisions effectively. Okay, so like we said before, there are 3 major common types of operationalizations in psychology. We're going to hash them out in a little bit more detail here. So you can have a self-report, an observational measure, or a physiological measure. That basically covers all, if not most, of the measurement types in the field of psychology. So self-report is any measurement technique that directly asks a participant how he or she thinks or feels or acts or behaves. We're just asking people to report maybe a little 3-item scale or a 5-item scale. From on a scale of 1 to 7, how much did you enjoy your meal tonight, right? Those sorts of things are very common forms of self-report variables or self-report measures. These are going to look like surveys, interviews, questionnaires. Right? We all interact with these a good bit. You will interact with these at the end of the semester when you do your evaluations of teaching for all of your courses. Right? That's a self-report survey or questionnaire where Georgia State is just asking you directly about your experience in the course. These are great because they're cheap and easy. I can get a lot of data really quickly for not a lot of money. Right? You can throw these things up online and get thousands of responses, in a matter of a few days or weeks, depending on how you sample people. It's just really convenient to get these data. It's easy. Also, an advantage is that you're getting data directly from the source, right? Directly from the individual that we are interested in, rather than sort of having to go around some other avenue and maybe make assumptions about the data. Of course, there are some real disadvantages to self-report measurement. People, and a lot of them, a lot of the disadvantages center around the fact that people make mistakes, right? They deceive themselves. So people classically very inaccurately answer questions about their health behaviors. So if your doctor asks you, for example, on average, how many alcoholic drinks do you have per week? People might go, maybe 3, 4, have a glass of wine here or there, with dinner, nothing crazy. And you kind of deceive yourself that 3 or 4 is how many drinks you have in, one night when you go out with your friends. And then you have a glass of wine with dinner, and then you have a beer at happy hour. And then you sort of, you mitigate your responses to make yourself feel better about the amount that you drink because it's not healthy, or the number of cigarettes that you smoke, or the number of times you have unprotected sex, right? These sorts of health behaviors are often underreported because people feel bad about doing them, and so they self-deceive. So a person might either purposefully or naively give the wrong answers. Social desirability, this sort of overlaps with that, right? Excuse me. You want to look desirable. So if if I asked you, how intelligent are you on a scale of 1 to 10? Right? Most people will put themselves above 5, right? They'll put themselves above average. But that's impossible, right? Most people can't be above average. You can't have 70% of people who are above the 50th percentile in intelligence, right? But people answer that way. People inflate these good things about themselves. How attractive do you think you are? How intelligent do you think you are? And then they tamper down the bad things about themselves. How much do you drink? How much do you smoke? How much unprotected sex do you have? How often do you drive without your seatbelt on? Those sorts of things. People want to look good for others. There are potential demand characteristics. This is kind of a strange term because I don't think the term tells you a whole lot about what it is, unfortunately. It's very simple, though. A demand characteristic is when the participant figures out what the researcher wants, or what they think the researcher wants. Right? So, for example, if you're at a restaurant and the waiter comes up to you and the waiter says, how have you enjoyed your service tonight? Right? Has everything been to your liking in the way that you've been treated here at the restaurant? Obviously, you know what they want. They want a positive response, right? So there are demand characteristics there where the participant has sort of figured out the experiment, so to speak. And then possible retrospective bias. Basically, this means people are really shitty at remembering the stuff they did. People are bad at remembering things from the past, and they might be biased in their responses. They might be inaccurate, right? So if I said, something like, "How often did you engage in dangerous driving behavior as a 16 or 17-year-old?" You're unlikely to accurately remember that, right? You're going to probably underreport your dangerous driving behaviors. One, maybe because of some social desirability, but two, it's just really difficult to remember that. You're going to be biased in the way that you remember it, whether to inflate or to decrease the response. So a big problem with self-report data is that they might not reflect actual behavior. So let's harken back to the Stanley Milgram experiment from our ethics chapter. If you remember, in this experiment, they had participants believing that they were shocking someone in the next room, even though they weren't. And some people shocked them all the way to death, right? It was apparent that if you hit this button, then the person is going to receive a shock so large that it could kill them. And people did it anyway, right? So behaviorally, Milgram gathered data that showed that people will actually act that out. They will actually do it when you put them in that situation. But now I want you to imagine that you took those people from the Milgram experiment and you just asked them, hey, do you think that you would ever shock someone to death because they missed a trivia question? I would imagine that 0 people would say yes to that, right? Their self-report would be, of course, I would never think about doing that. That's a terrible, immoral, unethical thing to do to someone, to shock them to potential death because they missed a trivia question. That's ridiculous. No one would ever do such a thing. So if we just asked for self-report, we get very different data from if we measured their behavior. And one would argue that the behavioral measure is more accurate. So that brings us to the next type of measurement, behavioral measures. If you're interested in someone's behavior or actions, don't ask them about it. you can simply set up a situation that allows you to measure their real world behaviors. Um, so, for example, if you're interested in over here on the right, maybe people's charitable donations, who they donate to, how much money they donate, you could ask people, right? Kind of like our taxes do, right? Just how much money did you donate to nonprofit charities this year? Um, and you're likely to get very inaccurate answers. Or we could set up a situation maybe in a laboratory or like on a college campus, um, where you have a table set up and you're literally giving people the opportunity to donate to charity, and you measure how much they donate, their actual real world behavior. Um, Maybe you're a developmental psychologist and you're interested in aggression in the classroom. And so, you could ask the children or you could ask the teacher to report on aggression, or you could go sit in the back of the classroom and observe the aggression, right? And count the number of aggressive acts and how long they last. And is it physical or verbal aggression, right? And you can literally physically be there, and note and measure the behaviors. So these are great, because it addresses the advantages essentially of self-report, because you're not putting the data through the person, through the participant, right? You're not asking them to report. So there's no self-deception. There's no social desirability. You're measuring their real behavior. So it addresses a lot of those disadvantages. We can get real-time data. In fact, now with lots of good technology, on smartphones or cameras, we can get real time behavioral measurements. In fact, I had a colleague who he was a social psychologist, and he did an experiment, on how situations affect people's behavior. And he had people wear like body cameras, like we often have police officers do. And it was basically a necklace that had a little body camera, and his participants wore it for like a week, and they recorded everything they did, and then they used those video recordings to analyze how situations affect people's behavior. The disadvantages, are that this can be time consuming, it can be expensive, it can be difficult to like set up the situation. The that camera study, the cameras are expensive. You need money, you need grants, to have 100 cameras that you give out to people. Then it takes a lot of time. He's got thousands of hours of video and audio to cull through. That's expensive, that's time. So these studies can be a little difficult occasionally. And in addition to that difficulty, if participants know that you are there or know that someone is watching them, they might behave differently. This is called participant reactivity. It's sort of think of the social desirability, disadvantage of self-report, but now we make it behavioral, right? Where if I have my body camera on all week, I might start to behave differently. I might not be as much of an asshole to people if I know that someone's going to watch the footage of me being an asshole to someone, right? So you might change your behavior, and behave unnaturally if you are aware that you are being watched. This is why often, when you do behavioral experiments and measures in a laboratory, you often take advantage of things like a one-way mirror. This is very common in educational settings or developmental psychology settings, where you might study play in children, and you want to have an unobtrusive measurement of their play. So you have a playroom where you bring children, and then next to the playroom is another room where you can watch the children play, but it's like a one-way mirror, right? The children can't see you, but you can see them. And so you decrease the likelihood of this issue of participant reactivity. So this is a problem, but there's ways around it, right? You can mitigate the effects of participant reactivity with, like I just said, unobtrusive measurement strategies. And our last operationalization style or category are physiological measures. Here's where we record actual real biological data, brain activity, hormone levels, heart rate, blood pressure, things of that nature, right? You are taking essentially samples of people's biological data. The sort of most common, maybe I won't say most common, the most advanced tool we have for studying the brain and brain activity is called fMRI, functional magnetic resonance imaging. So we can see over here on the right, you can see the structures of this person's brain, right? We can see the cortex here, we can see the limbic system, we can see the cerebellum, all this stuff. We can see the brain stem, right? You can actually see their nasal cavities and their throat. So an MRI, a magnetic resonance imaging, is just the physical picture, right, that allows us to sort of peer through the skin into the structures of the internal body. If you had knee surgery or shoulder surgery or elbow surgery, or if a doctor was worried that you have stomach cancer, then you would get an MRI because they're interested in looking at the physical structure, right? What damage did you do to your knee? What damage did you do to your shoulder? Which ligaments and tendons are torn? However, with the brain, we can layer on top of that MRI a functional aspect, right? That's what the F stands for. Functional meaning the activity of the brain. Basically, what happens is this machine, this is an MRI, it's outfitted to also measure blood flow in the brain. And we use the measurement of blood flow as a proxy for brain activity. So the hot spots, right, these red spots on the MRI are places in the brain that are receiving more blood than other places in the brain. What does that have to do with brain activity? Well, just like any other area of your body, when a piece of your body is active, it metabolizes nutrients and it creates waste. And the way that your body brings more nutrients to that area of the body and takes away the waste is through the circulatory system, blood flow, right? Imagine that you're doing bicep curls, right? You're working out, you're doing bicep curls. What happens to your biceps? Right? They're working, they're active, they're burning fuel, they're burning nutrients, they're creating a buildup of things like lactic acid. And so your body recognizes, hey, this is an area of the body that's working really hard. It needs more blood, and so it forces blood into your biceps, and that's what you sort of call like the pump from working out, right? When the muscles you've worked out feel like really tight and swollen and inflamed. That part of that is your body sending blood to those muscles so that it can bring it more nutrients and then take away the waste. Your brain is no different. If a piece of your brain is working really, really hard, then your body sends blood to that area of the brain to help it. And so we use this proxy of blood flow as a proxy for brain activity. Okay, so those are our categories of operationalization. A little bit more detail about them than we've gone into in the past. But now we're going to shift gears and we're going to talk about scales of measurement. So these are the types essentially of data that you can gather. So operationalization is more about how we move from a concept to something concrete, to something data oriented. Now that we have data, we can break the data down into different types of data, and there are numerous types of data. The first distinction we're going to make is categorical versus quantitative variables. And then we're going to make a second distinction, which are three types of quantitative variables. So the first question is, do you have a categorical or a quantitative variable, right? There's two options there. And then within quantitative, there are more options, right? Ordinal, interval, and ratio. We'll talk about each of those in turn. Here's just a quick little table that breaks down the definitions with some examples. Refer back to this if you have any questions, but we're going to go through and define each of these with some additional examples. Okay, categorical versus quantitative is really easy. Categorical variables put people into distinct groups. Things like sex, race, the species of animal, cancer diagnosis. Do you have cancer or do you not have cancer? Right? Is something trash or is something recyclable? Right? Categorical variables create bins. Right? They create categories, and then we put people into those categories based upon their data. Right? So things. Person level variables, right, are a really easy place to see this. Sexual orientation, ethnicity, race, sex, gender, age. You could say retired versus working, right? Anything like that. You can say education is a good one. Do you have a high school diploma? Do you have a college degree? Do you have a master's? Do you have a PhD, right? So anything that is going to create categories and then lump people into options of those categories. That's a categorical variable. A quantitative variable is when we assess a score with some meaningful number. So anything, and I don't want to say anything, most things that are numeric are going to be quantitative variables. So how quickly can you run a mile, right? 6 minutes and 42 seconds, right? It's a pretty quick mile. How much do you weigh? How tall are you? What's your IQ score? What is your GPA? All of those things produce a number, a quantity, that assesses some very specific, meaningful variable. Notice how someone's weight is not a category, right? You weigh 194 pounds, but we can take a quantitative variable and we can turn it into a category. So let's just take weight, for example. In many sports, you have weight classes. So boxing, UFC, wrestling, things of this nature. You basically take a segment of weights. So if you weigh 180 to 200 pounds, you're a light heavyweight. Right? And so within that, you have some variability. Someone can weigh 185, 187, 192, right? And so you could have different quantitative weight measurements that we then chunk and then turn it into a category like light heavyweight, featherweight, middleweight, those sorts of things. So you will often see quantitative variables sort of shifted into a categorical variable. Age ranges, right? Are you under 18 or over 18? Right? That's taking a quantitative variable, age, and turning it into a categorical variable. So that's very common for lots of practical reasons in the real world. Okay, so that distinction between categorical and quantitative is pretty straightforward. But now let's take quantitative, so numeric data, and let's further divide that into three types of numeric or quantitative data. So first, there are types of data that we call ordinal. This is easy to remember because ordinal data put people into an order, a ranked order. So you got first place, second place, third place, right, in the marathon. There's the number one selling, number two selling, number three selling book on Amazon or the New York Times bestsellers list. When you graduated high school, you probably got a class rank, right? You were 12 out of 150 or 45 out of 378 students, right? You were rank ordered. So anything that puts people into a rank order is an ordinal quantitative variable. Some other good examples that are maybe not quite so obvious are things like military rank, right? Military rank is an ordinal variable. Are you a private, sergeant, lieutenant, captain, major, colonel, general, right? And then there are even subdivisions within each of those ordinal ranks. Something else that's ordinal that's not quite so obvious is your class in school. So are you a freshman, a sophomore, a junior, a senior, right? It is essentially, in essence, they seem like categorical variables, but they're actually ordinal because there's a structured order to them, right? Freshmen have the fewest credits, sophomores are next, juniors are next, seniors have the most credits, right? So there's a meaningful quantitative order to those variables versus something like ethnicity, which doesn't have a hierarchy, right? There's no order of ethnicity. There's no first, second, third, fourth when we're talking about race or ethnicity. So ordinal variables put people into a meaningful order. Interval variables are numbers that represent equal intervals between levels, but there is no true 0 point. Now, this is, I think, the most difficult one of these to understand, so we're going to spend a minute on it. I'll say that again. Scores or numbers represent equal intervals between the scores. So when you go from 4 to 5, it's the same distance as 5 to 6 or 6 to 7. But there's no true 0. So something like temperature is an interval variable because, yes, we have a 0 degrees in Fahrenheit and Celsius, but it's not a true 0 because that 0 doesn't mean the absence of the variable, the absence of temperature. Right? There is no such thing as the absence of temperature. It is simply a sliding scale, right? Where if I go from 10 degrees to 15 degrees, right, it's the same change as 15 degrees to 20 degrees, 20 degrees to 25 degrees, and there's no 0 point. Lots of survey data are interval quantitative variables. So on a scale of 1 to 7, how much do you enjoy this course? Right? There's no 0 because you can't have an absence of enjoyment of this course. Your enjoyment is along a scale from 1 to 7, right? We're moving from 1 to 2 and 2 to 3 and 3 to 4 represent the same sort of incremental increase in enjoyment. Also, something like IQ is interval because you can't have a 0 IQ, right? If you have a 0 IQ, you don't exist, right? You are not a conscious being. And so, we can give people a score on this scale of IQ, but there's no true 0 point where 0 equals the absence of whatever we're measuring. Right? That's what true 0 means. So when something has a true 0, we call it a ratio variable. So things with true zeros are like the number of siblings that you have, right? If you answer 0, it means the absence of siblings. Ounces of milk in your refrigerator, right? Someone might have 30 ounces of milk in the refrigerator right now. Someone else might have 0 ounces of milk, and that 0 means the absence of milk, the lack of milk. So anything where, again, numbers represent equal change and equal interval along the scale, and that scale has a true 0, where 0 means the absence of the variable. So ordinal, rank order, interval, there's no true 0, ratio, there is a true zero. So these are our three types of quantitative variables. So maybe a good practice would be to go ahead and pause here for a minute and just see if you can come up with two examples of each of our four types of variables: categorical, quantitative ordinal, quantitative interval, quantitative ratio. So just, rack your brain for a minute, come up with two examples of each that we haven't discussed. And if you got some friends in the class, maybe, share your examples with them, maybe double check your examples, Google to see what they are, just to sort of get you thinking about how to find these out in the real world. So go ahead and press pause, do that for a minute, and then press play, and we'll move on with the lecture. All right, I hope you're back. And we'll move on now to, now that we've sort of defined the types of variables and the types of measurements that exist, we need to know how to measure them well, how to measure variables correctly, and how we know whether we are measuring them correctly. So our first concept here is going to be the concept of reliability. Reliability is basically measurement consistency. So how consistent over time is a measurement tool. And then within a measurement, how consistent are each of the questions with each other. Those are essentially what we mean by reliability. We're going to go through three types of reliability here: test, retest, interrater, and internal reliability. So test, retest reliability is the consistency over time of an individual's scores on a given measurement. So what you have here is a table of data on the satisfaction with life scale. So it's, I don't know, I think it's like a 15 or 20 item survey where people answer questions, and the goal of the survey is to assess how satisfied they are with their life. In order for this to be a good measurement, we would assume that the closer in time to test, retest, meaning I give you the life satisfaction scale maybe on Monday, and then I give it to you again on Wednesday, right? Only 2 days, or maybe the next week. So you have a very tight window of test, retest, right? We tested you. Now we're retesting your satisfaction with life. We would expect that with a small test, retest window, people's scores would remain very similar, right? Because it's unlikely that your satisfaction with life changes dramatically in a span of 2 days or a week, right? So we would want to see very high test, retest reliability on a short time scale for this particular satisfaction with life survey scale. However, as our time between test and retest increases, we might expect to see less reliability over time, meaning that your scores will start to differ. Because if I test you from day one to a week later, we expect your score to maintain some consistency. If I wait a year, if I wait 2 years, if I wait 5 years, then we would expect life satisfaction to potentially change. So we would expect test, retest reliability to decrease over time for this. And in fact, this table shows us just that. So over here we have 1, 2, 3, 4, 5, 6 experiments, right? These are citations, so 6 published studies that used the satisfaction with life scale. And we're going to look at these 2 columns over here on the right. Test, retest, these are correlations. If you remember from a couple chapters ago, a correlation gets stronger as it approaches 1 or -1, and it gets weaker as it approaches 0. So the larger the number here, the more reliable, the more consistent the scores. And so we see when you have an interval of 2 weeks for your test-retest reliability, we have very high consistency, a very high correlation, right? It's approaching 1. 1 month, we're still very high. So that means we tested people's satisfaction with life. We waited a month and we tested their satisfaction again. However, when we get out to things like 2 months or 10 weeks of time, we start to see some decreases in the correlation between test time 1 and test time 2, meaning 2 months or 10 weeks is enough time for some shit to happen to either increase your satisfaction with life or decrease your satisfaction with life, right? 2 months, 10 weeks, 2.5 months, 3 months, there's a lot of stuff that can happen. And so we start to see people's scores become less reliable over time. And down here, if we wait 4 years, right, then we get only a moderate correlation, meaning 4 years is a lot of time for something to happen. So we might anticipate that the correlation in test-retest reliability would decrease. So some variables, we want to see very high test-retest reliability. In general, we want that, right? If I give you an IQ test today, an IQ test is supposed to measure your invariant intelligence, right? It's sort of an internal variable. How intelligent are you? And so we don't want that to change over time, right? If you had an IQ of 120 today, and I gave you an IQ test tomorrow, and you got an 85, you didn't suddenly become a different person in one day. I have a problem with my measurement, right? I have an unreliable measurement tool. So something like IQ, we want very high test-retest reliability. Something like life satisfaction, we would expect very high test-retest reliability over short intervals, and we would expect to see that reliability decrease with longer intervals. It just makes sense for what the variable is. So in general, we want very high test-retest reliability, especially over short intervals. Okay. Our next type of, sorry about that. Our next type of reliability is what we call Interrater reliability. So oftentimes in observational studies, we want to maybe record video or audio, or maybe have someone give like for example, a writing sample. And then from that video, from that audio, from the written sample, we have people who work for the lab rate something about the observation that we're making. So, for example, imagine that we're trying to study happiness in children. And we take some video and audio of a school classroom for a day. And so we want to get ratings of happiness. And so we have research assistants who watch those videos and they pick out a particular child, right? And they give a rating from 1 to 10 on how happy they think that child is across the day. Here we have some fictional data. On the y-axis, we have Matt's ratings. So this is research assistant Matt. On the x-axis, we have research assistant Mark. And we have 2 children who they are rating for happiness that we're highlighting, Jackie and Jay. So Matt rated Jackie on her happiness. Matt rated Jay on happiness. Mark rated Jackie on happiness, and Mark rated Jay on happiness. And so what we want to see is, do Matt and Mark's ratings align with each other? Because if Matt is giving Jackie a 10 and Mark is giving Jackie a 2, something's wrong, right? The child cannot be extremely happy or extremely unhappy, at the same time. So we have an issue with the reliability of our ratings. So here we see that Matt and Mark have good inter-rater reliability, because when Matt rates someone low, Mark tends to rate them low on happiness. When Matt rates someone high, Mark tends to rate someone high. Right? Their ratings are in close agreement with each other. So they both see that Jay is very happy, and they both see that Jackie is kind of sad. Right? She's not very happy. So this would be an example of good inter-rater reliability. We quantify it with a correlation, right? Our scatter plots, and we could calculate a correlation coefficient for their ratings. However, over here, we've swapped out one of our observers, one of our research assistants. Now we have Peter's ratings compared to Mark's ratings, and we see that Peter and Mark are kind of all over the place. They don't really agree on the happiness of our children. So we can see that Peter thought that Jackie is pretty happy, right? That's like a 7. Whereas Mark rated her as a 2. So which is it, right? We don't know. It's problematic. It's a problematic measurement because Mark and Peter can't agree. There's no reliability between their ratings. The same thing with Jay, right? Mark says that Jay is a 9 on happiness, but Peter says that Jay is like a 6 on happiness, right? It's a problem. And we can see from sort of the scattered spread shot of their scatter plot that they're not in agreement, right? Their ratings are all over the place. And so this would represent poor inter-rater reliability. We have a problem, right? We got to fix it somehow. Okay, so what I want you to do is maybe snag this link and watch this video for just a couple minutes. And I want you to focus on the girl in yellow. You'll see her. This is a video of a classroom, I think a preschool classroom. And what I want you to do, sorry, this was set up to actually kind of do in class, but we can still do it from a distance. What I want you to do is focus on the girl in yellow, and I want you to record how many times she looks away from the teacher. I want you to record and write down how many times she claps. And I want you to write down how many times she puts her hands in her lap, right? So we're counting these observational behaviors for the girl in yellow. What I want you to do is notice that it would be quite possible for different raters to get different ratings, right? Different observations from these behaviors. If I don't train you very well, right? So go into this with like no training, and notice that some of the behaviors might be ambiguous. Some of the time you might be able to like interpret it one way or another, or did that really count as looking away from the teacher or not? And if she goes like this, right, that's a clap. But if her hands don't touch, is it a clap? If she just puts her hands together, does that count as a clap, right? There's ambiguity in these behaviors in this video. So I want you to watch the video, try to do this task, and just sort of notice that suddenly the reliability of people's ratings is pretty easy to call into question, and it's pretty easy to get differences. And so what this tells us is that preparation is very important for these inter-rater measurement tools. We really want to have some training for our raters to make sure that they're all sort of on the same page. Because if you're not on the same page, then you can have some problems. So go ahead and do that, and then just pick back up with the lecture. Okay, our last form of reliability is called internal reliability. This is not to be confused with internal validity. I know that's a little confusing, but these are two different concepts. We're going to talk about internal reliability. This is the extent to which multiple items within a measurement are answered in the same way by the same person. Let's see an example of that before we sort of move on. Here we have 5 questions from a life satisfaction scale. And imagine that people are rating from 1 to 5 or 1 to 7. How much do you agree with this statement, right? 1 would be, no agreement. 7 would be high agreement. So in most ways, my life is close to my ideal, right? 1 to 7. The conditions of my life are excellent. 1 to 7. I'm fond of polka dots. 1 to 7. I'm a good swimmer. 1 to 7. If I could live my life over, I would change almost nothing. 1 to 7. So internal reliability is the idea that if this is a life satisfaction scale, then questions 1, 2, and 5 should be answered very similarly, right? Because these questions are assessing how much someone is satisfied with their life, right? My life is close to my ideal. A high rating there means high life satisfaction. Conditions of my life are excellent. Right? A high rating means high life satisfaction. If I could live my life over, I would change almost nothing. A high rating would mean high life satisfaction. So questions 1, 2, and 5 should correlate very closely with each other. If you respond with a 7 or a 6 on one of those, you should respond with a high number on the others. Versus polka dots and being a good swimmer, which shouldn't really have anything to do with your life satisfaction. And so we should find that the answers to those questions don't really need to correlate with the answers to the life satisfaction questions. Right? So we can test for internal reliability the extent to which the items in a measurement tool sort of coalesce. And we want high internal reliability, right? We would expect questions 1, 2, and 5 to have high correlations, and we would expect them to not really be correlated with the answers to questions 3 or 4. So of course, there's a way that we can quantify this and assess internal reliability. It's called Cronbach's alpha. It's not super important for you to understand the mechanics or the math behind its calculation. Just know that it's basically doing a whole bunch of what we call inter-item correlations, and it's getting an assessment of how much do the items correlate with the other items. And so we're going to go back to our table about life satisfaction. And if we look at this column called coefficient alpha, it's just another name for Cronbach's alpha. We can see these sort of, just think of them as the average correlations between our items on the scale. We can see 0.89, 0.85, sort of a range around 0.8, 0.87, so on and so forth. If we remember about correlations, right, as we approach 1, it gets stronger. And so these results tell us that we have good inter-item correlations, right? We have high internal reliability because our Cronbach's alpha, our correlations among the items are approaching 1. They're very high. In general, we want to see a Cronbach's alpha greater than 0.7. That's kind of the standard in the field. If you're around 0.7 or below 0.7, then we start to question the internal reliability of your measurement. It means your individual questions are sort of all over the place, right? The responses aren't coalescing into a single measurement. Anything that's substantially above 0.7, we're happy with in general. Okay, so we're going to stop there. We're a good bit more than halfway, but we've been going for a while. So we'll stop. It's a good stopping place because we're going to move into what's known as validity of measurement. So this will end part 1. Make sure you pick up part 2, where we'll discuss validity of measurement. And part 2 is going to be substantially shorter. I think we've only got maybe 12 or 13 slides to finish this up. So thanks for watching, and I will see you for part 2.